The more I use this Algodo simulation, the more impressed I get. In fact, we're actually going to use the simulation to generate data for our Chapter 9 lab. Here's the approach I'd like to take. What I'm going to do is create 3 objects that are free to rotate. And we're going to rotate each of those objects with a fixed force. And the goal is to figure out the moment of inertia of each of the 3 objects. We're going to start with just a regular old sphere, and I'm going to make it have a radius of 1.20 meters. Okay, now I'm going to give this sphere an axis of rotation right in the center, as close to the center as I can get it. Okay, now I'm going to turn off gravity and I'm going to turn off air resistance so that these things are free to rotate without friction and without any weird forces acting on them from gravity. Okay, so here's one object. And just to illustrate that it's free to rotate, I can grab it here and send it rotating. Okay, so there's the first object. I'm going to create the other 2 objects. The second object I'm going to make is going to be just a bar. Okay, so I'll make it 0.25 meters wide and how about 1.85 meters long. Okay, and I'm going to give that an axis to rotate on as well, as close to the center as I can. Oh, I can do a little better. Okay, and then the third object, I'm going to create a circle that has a radius of 1 meter, but I'm going to turn it into a kind of a crazy shape. So this will be 1.00 meters. I'm going to slice away at it and turn it into something a little more crazy. So let's do something like this. I'm going to slice up like that, cut out there, like that, maybe do a little zigzagging, and cut way in. Alright, so this is just a crazy, crazy shape. Okay, and here's cool, I'll just liquefy this. Oh, it's stuck. Let me just erase it. There it goes. Alright, and I'm going to try to add an axis again here close to the center. Okay, the goal here is going to be to try to measure the moment of inertia, or I, for each of these 3 objects. Okay, now the way we're going to do that is I'm going to apply a constant force to each of these, and I can do that with this thruster. So I'm going to go right to the edge of the circle, and I'm going to apply a thruster that pushes tangentially. Okay, and I want to set its thruster so this is exactly 1 newton of force. Actually, let's do 0.5 newtons. 0.50 newtons of force. Okie dokie. And here's what I can do now, alright? So I can set this into motion, and we can watch what happens, right? The force is going to push. It's going to cause this disk to accelerate and go faster and faster. Now, the acceleration, the actual angular acceleration of this disk should depend on the moment of inertia of the disk. So what we're going to do is this. I want to collect some data from this, and the simulation allows me to do that in a pretty cool way. Oops, I want to erase that. I'm going to click on it here, and I'm going to get show plot. So this will actually graph for me information about this circle. So on the x-axis, I'm going to have time, and on the y-axis, I'm going to measure the angular speed. Okay, and I'll collect this data for you for 10 seconds. Okay, and then I'll provide you with that data so that you can analyze it to try to determine the moment of inertia. Alright, so let's collect this data. Here we go. Boom. You know what? I don't think it started with 0. Let's make sure it has 0 velocity at the start. Okay, so velocity 0. Okay, and now here we go. Okay, it's starting its acceleration. Alright, and we'll stop it right there. Okay, now I'm going to export this as a CSV file. This is something then that can be saved, and I'll provide that data with you. Sorry, I'll provide it to you so that you can analyze it using Logger Pro. Alright, I'm going to do the same thing for the other 2 objects. So let's get rid of this thruster, and I'm going to put a thruster on this guy right here. So, okay, now I told you how long it was, and this axis is supposedly right in the middle. So I'm going to add a thruster right on the end. And again, I'm going to give it a force of 0.5 newtons. 0.50, in fact. Okay, and again, we're going to look at a graph, and I'll provide you with this data of the angular velocity versus time. Okay, we'll put this to 20 seconds, and we'll say, ready, set, go. Seems to be going quite a bit faster, doesn't it? Okay, so we'll stop it there. I'll save that data. All right, and we'll get rid of that booster. Okay, now we'll do the last object. Now, I intentionally kept a piece of this, the length of the actual radius of the circle, right? So this was a 1 meter circle at the start, and you'll see, let me get rid of that. This was a 1 meter circle, and so this edge right here is 1 meter from the center, right? So that's good. So we can figure out how far the booster is from our axis. Okay, so let me put the thruster on here. Okay, so here's our thruster. It also is going tangential here, and we'll do it 0.50 newtons. All right, let me just double check that. Okay, we're good. And I will turn on this graph as well. Show a plot of angular velocity versus time. All right, and we will hit play. Okay, there it goes, spinning away. All right, and I will pause it right there. Save that. Okay, so that's the data collection. For this lab, I've done the data collection for you. Your challenge is going to be to analyze this data, which is angular velocity versus time, in an effort to figure out what the moment of inertia is of each of these three objects.